The TCP/IP protocol suite is just that. It's a suite of many protocols, one of which is the Address Resolution Protocol, otherwise called ARP. The ARP protocol is used to map IP addresses to the hardware address of a network interface. In other words, the MAC address, sometimes also called the physical address. It's a 48-bit hexadecimal address. That's a MAC address. And if you have an Ethernet wired type of network interface, it has a MAC address. If you have a Wi-Fi card, it has a MAC address. If you have a Bluetooth card, it has a MAC address. So anything that communicates on the network is going to have a MAC address. But the interesting thing about Address Resolution Protocol, it's one of those TCP/IP protocols that only applies to some layers of the OSI model. And you'll remember that Mike talked about the OSI model for us. Let's apply the OSI model to talking about how ARP is really local area network traffic only. And to do that, let's go into a packet capture in Wireshark. So here in Wireshark, I'm going to filter for ARP traffic by typing ARP up in the filter line, and I'll press enter. And so as a result, we're only looking at Address Resolution Protocol type of traffic. Again, that's really saying if I want to connect to a given IP address on the LAN, what I really need to know is its MAC address. That's what ARP does. So let's break down the packet headers for ARP. So I'm going to select one of these ARP packets randomly, doesn't matter which one. And in Wireshark, in the middle panel is where we have the packet headers. So the first one is the Ethernet 2 header. Now that maps to OSI layer 2, the data link layer that Mike talked about earlier. That means that we're dealing with MAC addresses. We have a source and destination MAC address. Those are just hardware addresses for a network interface. And that's what's actually used to communicate on a local area network, a LAN. If we go down a little bit further in the packet headers, we have an ARP header, Address Resolution Protocol. And it just has some details about what's happening, whether it's a broadcast or that type of thing. But what's interesting is what's not here. What does that mean? Well, that's the end of the packet headers. Wait a minute, where's the IP header with the IP addresses? You only need an IP header if you need to talk outside of a local area network. Because on a LAN with ARP, you're really only talking to the MAC address. That's why in an ARP packet, you're not going to have an IP header or a TCP header following that and so on. So really what we're saying is that the IP header then must map to layer 3 of the OSI model, which it does, if layer 2 of the OSI model deals with MAC addresses. So that's how we're kind of correlating the OSI model Mike was talking about with what we're seeing here in a packet capture. You might remember from an earlier discussion, we talked about common Windows commands, one of which was the ARP command. Let's just look at that very quickly once again. Here in Windows, I'm going to go to the Start menu and type in CMD to open a command prompt where I'm going to type in ARP-A to view all of the entries in my ARP cache. This is the mapping we have in memory on every device of IP addresses and the mapping to a MAC address only for local area network devices. So if you're hitting a website outside of your local area network, you will not see the IP address of that website and its MAC address here. It's not how it works because ARP is only for the LAN. But what you will see as a result of connecting to that website is you would see the IP address of your default gateway and its MAC address. That's your nearest local area network point for you to have made that connection to that website. Okay, so now that we know a lot about Address Resolution Protocol, we can talk about ARP Cache Poisoning. This is a type of man-in-the-middle attack, otherwise called an on-path attack. Now, what do you mean, man-in-the-middle? Why is it called that? We'll get to that in just a moment when we look at an animation. But the general concept with ARP Cache Poisoning is that a malicious actor somehow, some way, gets on your network. Heaven forbid, but that's what happens. They get on the network. If they can get on the network, they can issue an ARP cache poisoning attack, which, generally speaking, will force everyone's traffic that might be normally headed for the default gateway to get out to the internet. Instead, it sends it through the attacker machine. So the attacker sees everything, hence man in the middle. But really, how does that work in a bit more detail? Well, let's take a look at that through an animation. So in step number 1, we have the attacker that already somehow got on the network. So we'll assume that that has been done. In our diagram, notice that we have a default gateway on our local area network. That's the router. And we're going to use that to get out to the internet. Now, we have to look at the addresses for this to make sense. So let's say the MAC address of our default gateway, the hardware address of its network interface on our LAN, is all 4s, to make it simple. And let's say its IP address is 192.168.1.1. Okay, that's our router, our default gateway, our way to get to the internet. And our attacker is on the network. So in step 1, what the attacker is going to do is say, okay, I need to force everyone's traffic through me, when it's normally going to go through the router, out to the internet. So the attacker can send out a transmission to everyone on the network, a broadcast saying, hey everyone, I would like you to please update your ARP cache in memory, which we just looked at with ARP-A in Windows. Update your ARP cache for the entry of 192.168.1.1. That's already going to be there for everyone. It's the default gateway. Change the MAC address to 112233445566. That would be the MAC address of the attacker's station. We know that that is not the MAC address of the default gateway, is it? It's not. So that's the type of ARP broadcast that would be sent out. It's a malicious transmission. So in step 2, the victim devices on the network will say, okay, I've done it. So now on a victim machine, if we were to type ARP-A, we would have the correct IP address of the default gateway, but we would have the MAC address that it's mapped to being the attacker's MAC address. Now, everyone's traffic before it goes out to the internet will first go through the attacker's system. Then the attacker presumably would have configured routing so that the traffic continues on through the real router out to the internet. That means that victims are none the wiser. They don't even know what's happening. Now, why is it dangerous for an attacker to see all network traffic? Anything an attacker can see about our network, how it's configured, the type of traffic, the amount of traffic, the stations on the network, the sites we're visiting, that's bad news. That is an ARP cache poisoning attack. Now, what can we do to mitigate against that? Because it sounds really scary. Well, what we could do is configure our devices, like Windows machines, Linux machines, switches, routers, anything on the network. We can configure them to only allow static ARP cache entries. That means that we configure a preloaded list of what should be in the ARP cache, and essentially, you can think of it as being read-only. We don't allow it to be changed when we get an ARP broadcast update on the network. And of course, in the first place, the attacker had to get on the network. How about we take steps to prevent that from happening? And we could do that in a number of ways, like using network access control mechanisms, maybe requiring smart card authentication just to get on the LAN in the first place, let alone access anything on it. Using multi-factor authentication, maybe instead of or in addition to smart cards and usernames and passwords. If you're using a smart card in addition to a username or in addition to a PIN, you already have multi-factor authentication. That's a great way to control who can get on the network. Maybe conditional access policies on the network that say only these known devices are allowed on the network after successful authentication. So there are many ways that we can mitigate these types of threats, but you can only mitigate it if you truly understand it.